Now we will do integration by using trigonometric identities. We have studied the identities 2 sin A cos B, sin A plus B plus sin A minus B, 2 cos A sin B, sin A plus B minus sin A minus B, 2 cos A cos B, cos A plus B plus cos A minus B, 2 sin A sin B, cos A minus B minus cos A plus B. And sin square x 1 minus cos 2x whole divided by 2, cos square x 1 plus cos 2x whole divided by 2, sin cube x 3 sin x minus sin 3x whole divided by 4, cos cube x cos 3x plus 3 cos x whole divided by 4. See, all these identities we have studied. So in this exercise 7.3 we have to use these 8 identities for integration. So here I will show you how we get this identity. We have studied all these identities. We have studied in 11th standard. See here, sin A plus B. Remember what is sin A plus B? Sin A plus B is equal to sin A cos B plus cos A sin B. Sin A plus B, sin A cos B plus cos A sin B. Then sin A minus B. Sin A minus B, sin A cos B minus cos A sin B. So when we add these two equations, what we get? Sin A plus B plus sin A minus B. We add right side. Sin A cos B plus sin A cos B, 2 sin A cos B. Cos A sin B minus cos A sin B, that will be cancelled. So we get 2 sin A cos B. See, this is the first formula. 2 sin A cos B equal to sin A plus B plus sin A minus B. So when we add sin A plus B and sin A minus B, we get 2 sin A cos B. So that is one formula. Similarly, if you subtract this, sin A plus B minus sin A minus B, so this term will be cancelled. And we get 2 cos A sin B. Cos A sin B minus minus. So plus. So 2 cos A sin B we get. See, 2 cos A sin B, sin A plus B minus sin A minus B. Similarly, what is cos A plus B? Cos A cos B minus sin A sin B. Cos A plus B is cos A cos B minus sin A sin B. And cos A minus B is cos A cos B plus sin A sin B. So when we add cos A plus B and cos A minus B, we get 2 cos A cos B. And when we subtract cos A plus B minus cos A minus B, we get minus. To avoid that minus, we are subtracting cos A minus B minus cos A plus B. So we get only positive 2 sin A sin B. So we get, using this simplification only, we get this formula. So we have to study these 4 formula, this 8 formula. So you have to write down all these 4 plus 4, 8 identities. All these are identities. So 2 sin A cos B, sin A plus B plus sin A minus B. 2 cos A sin B, sin A plus B minus sin A minus B. Cos A, then 2 cos A cos B, this one, 2 sin A sin B, cos A minus B minus cos A plus B. So these 4 plus. Now these 4. See how we get this formula, sin square x equal to 1 minus cos 2x whole divided by 2. That formula, now these two formula we get from the formula cos 2x. See, we know what is cos 2x. For cos 2x we have studied for many formula. 2 cos square x minus 1, 1 minus 2 sin square x. From those two formula we are getting these equations. So cos 2x, one formula 2 cos square x minus 1. From this, when we take minus 1 this side, we get 1 plus cos 2x equal to 2 cos square x. So what is cos square x? 1 plus cos 2x whole divided by 2. 1 plus cos 2x whole divided by 2 is equal to cos square x. So we get cos square x equal to 1 plus cos 2x whole divided by 2. So from this formula only we are getting that. So cos square x equal to 1 plus cos 2x whole divided by 2. So you have to use that formula to find the integrals of these functions. Now next, one more formula we have studied, cos 2x equal to 1 minus 2 sin square x. 1 minus 2 sin square x. Cos 2x equal to 1 minus 2 sin square x. From this formula, when we take 2 sin square x this side, cos 2x that side, what we get? 2 sin square x is equal to 1 minus cos 2x. So sin square x is equal to 1 minus cos 2x whole divided by 2. So from saying this formula, we have studied all these. So from that same formula, we are getting all these. So we get, from this equation we get sin square x equal to 1 minus cos 2x whole divided by 2. So that is what first formula. Sin square x equal to 1 minus cos 2x whole divided by 2. Whole divided by 2. So sin square x 1 minus cos 2x whole divided by 2. Cos square x 1 plus cos 2x whole divided by 2. Only small difference, plus and minus. So 1 minus is for sin square x, plus is for cos square. So 1 minus cos 2x whole divided by 2 we have to use for sin square x. And for cos square x we have to use 1 plus cos 2x whole divided by 2. So to find the integral of sin square x, we have to use this identity. Then only we can integrate. Similarly, for to find the integral of cos square x, we have to use this identity. Then we have to integrate. Then similarly, sin cube x, we know how we get these two formula. These two formula we get from the identity sin 3x and cos 3x. What is sin 3x? Sin 3x equal to 3 sin x minus 4 sin cube x. Sin 3x equal to 3 sin x minus 4 sin cube x. So minus 4 sin cube x we take left side. So what is 4 sin cube x? Equal to 3 sin x. 3 sin x. Sin 3x take this side. Minus sin 3x. 3 sin x minus sin 3x. So sin cube x. What is sin cube x? Sin cube x equal to 3 sin x minus sin 3x whole divided by 4. So that is what this formula. Sin cube x equal to 3 sin x minus sin 3x whole divided by 4. That is sin cube x. So then what is the formula? Cos 3x. Cos 3x equal to 4 cos cube x. 4 cos cube x minus 3 cos x. So this is the formula for cos 3x. We have studied for in 11th standard we have studied. Cos 3x equal to 4 cos cube x minus 3 cos x. From this, find the value of cos cube x minus 3 cos x. Take this side. So cos 3x plus 3 cos x equal to 4 cos cube x. So from this, what is cos cube x? Cos cube x equal to cos 3x plus 3 cos x whole divided by 4. So see this formula. Cos 3x plus 3 cos x whole divided by 4 equal to cos cube x. So we use these identities to find the integral of cos cube x, sin cube x, cos square x, sin square x. See, so we know integral of sin x. We know integral of sin x. See here. Integral of sin x. What is the integral of sin x? Integral of sin x. Integral of sin x equal to minus cos x. Minus cos x plus c. So integral of sin x is minus cos x plus c. What is the integral of sin 2x? What is the integral of sin 2x? Integral of sin x minus cos x plus c. Remember that method I told you in the standard formula. In the place of x, if there is any other function of x, we can do directly integration. How we can do? What is integral of sin 2x? Integral of sin 2x, we can see in the place of x here 2x. So what we can write? Minus cos 2x. So instead of x, we have to write 2x. Immediately divide by what? When we find the integral, we divide. Divide by derivative of 2x. What's the derivative of 2x? 2. So divide by 2. So answer we get. So in the place of x, 2x, 3x, 2x plus 1, 3x plus 1. Though in all these cases, we can find the integral directly. No problem. But if instead of sin x, if it is sin square x, we can't do. We can do only by using this identity. So sin square x, to find the integral of sin square x, we have to use this formula. First writes, instead of sin square x, write 1 minus cos 2x whole divided by 2. And for cos square x, we have to write 1 plus cos 2x whole divided by 2. Then we can find the integral. Because see here, in the right side, 1 by 2 constant, we can take outside. So to find the integral of sin square x, if you use this formula, then integration become very easy. Because 1 by 2 we can take outside into integral of 1 x minus integral of cos 2x sin 2x by 2. See, I told you, integral of cos sin 2x, integral cos 2x, that we can write directly because in the place of x, a function is there whose derivative is a constant. So by dividing by that constant, the integration will be over. So if in the place of x, multiple angles, In the place of x, 2x, 3x, 2x plus 1, 3x plus 1. In all those cases, derivative of that function is only a constant. So we can do the integral directly. So no problem. But sine square x, cos square x, sine cube x, cos cube x. Only by using this identity we can integrate. So remember that method. So we have to remember these 4 plus 4, 8 identities to find the integrals in this exercise 7.3. So study all these in identities. So sine square x 1 minus cos 2x whole divided by 2. So remember this method, different methods we are using for integration. So sine square x, cos square x, remember this method. Use this identity. Integral of sine square x that is equal to integral of that. Then all these. So remember all these identities. So now we'll do these questions. So remember this identity also to find the integral of sine A cos B. You have to use this identity, then we have to integrate. Then easy to integrate. See here this side sine A plus B, sine of something, sine some function. We can find the integral. So using this, applying this identity, we can find the integral. So now we'll do the integrals of these functions, sine square x. So first one we'll do integral of sine square x dx. So to find the integral of sine square x dx, you have to use that identity. So instead of sine square x, we have to write 1 minus cos 2x whole divided by 2 dx. That is equal to 1 by 2 constant, take outside. See this by 2, whole divided by 2, take outside. Into integral 1 minus cos 2x dx. Now we can write directly 1 by 2 into, what is the integral of 1? So put bracket because for both the terms 1 by 2 is applicable. That means we have to multiply by 1 by 2. So put in bracket. So 1 integral of 1 x integral 1 dx, that is integral 1 x minus, what is the integral of cos 2x sin 2x divided by 2? I told you integral cos x sin x. So integral of cos 2x sin 2x divided by derivative of that 2x, that is 2 plus c. So here you say actually we by substitution method we are getting this, but we have to write directly. So integral of cos 2x, cos 3x, all that we can write directly. So integral of cos 2x sin 2x by 2 plus c. So that is the answer. So next we will do in the next session.